We sit between two vast tide generating systems, one just off the coast of Norway, one just off the coast of Iceland. This means that Scotland in particular sits in the middle of a vast tidal wave system. The net result is almost every one of these inlets on the west coast, and particularly through the islands off the north coast of Scotland, are subject to very intense tidal currents, with kinetic energy densities that quite frankly make wind power and solar power look rather silly in comparisons, by a factor of about 10 at the extreme. We've been able to model this resource for perhaps about 10, 12 years now. This is the Pentland Firth off the north coast of Scotland. If I have time, I'll say a little bit more about this. There's the Scottish mainland, there is the southern part of Orkney. We don't really know what size that resource is. I believe that the ultimate developmental limit is about 17 gigawatts. I think a more reasonable estimate is just under 9 gigawatts, taking into account environmental implications. That's a real potential for development for the future, but we're not there yet. If we want to consider the resource, and this is something where a lot of renewable energy proponents get quite vague about, just what does the resource mean? We've got a theoretical resource, the ultimate resource that we could get. That's nonsense. I get quite alarmed when I read academic papers talking about theoretical tidal resource of location X. It's almost meaningless. I'm an engineer, not interested in fantasy like the theoretical resource. Much more interested in the technical resource, how much of it we could actually extract using any conceivable engineering. I'm even more interested in the practical resource, how much of that it would be acceptable for us to extract, taking into account constraints, social, environmental, economic. That's what we should really be concentrating on. Each one of these, every 6 months goes by, I think we fine up our estimates quite drastically on these as we understand more and more of where they are. I hate being asked how much energy we have, but I'm going to try and guess it. I'm revising this estimate. Wave power, I think in Europe, we could be looking at a practical resource of about 50 gigawatts installed. I won't say the timescales of that yet. There's a lot of discussion goes on about this. Most of it's reasonably good-natured and relatively well-informed. Tidal resource, and I'm talking about tidal current here, not tidal barrages. I think we're looking at about 25 gigawatts, about half the prospect of wave power. There's also a lot of discussion that goes on around the tidal resource. Unfortunately, an awful lot of it, I think, is based on imagination and fantasy on occasion. I've heard vast figures up in the hundreds of gigawatts handed out with straight faces, and I've heard estimates down in about the 1 or 2 gigawatts. So I think the best available information puts it somewhere of the order of 25. But it doesn't matter how you interpret these. They do look at a real prospect for energy for the British Isles. Most of that is in the British Isles, the UK and Ireland, which is really why we're interested in it. Okay, just say a little bit about research. What's going on at the moment? A substantial amount of our research effort in the UK is based about the resource, not too surprisingly. Just how much is that resource and how much of it can we extract safely? Or safely, economically and sustainably. If we can't extract this resource sustainably, then we're wasting our time. We've just got yet another environmentally destructive process. So we have to identify what the acceptable limits of extraction are and where should we be looking. This starts to have to draw input from the sociologists. What is an acceptable resource? I don't know. I have my own ideas. Other people will have their own ideas. It's amazing how little overlap there sometimes is between these discussions. Also, the machines themselves. Most of the original work for wave power was way back in the 70s. What should these machines look like? What should be the physical modes of operation of them? How do we fix them in place? What should they be made of? What kind of materials are we dealing with? We look at tidal. Again, we need to know what could be the physical, mechanical engineering principles. I think in tidal, the real difficulty is how do we fix them on the seabed without them being destroyed by the very resource they're trying to harness? And how do we install them in this, quite frankly, disgusting operating environment? And never forget environmental impact. I think there are real questions about the tidal devices to make sure that they're extracting the energy in an environmentally acceptable way. I've seen designs of tidal turbine that I would not accept. I think it's an issue of design, however. And again, I will come back to that in the conclusions. It's hardly surprising that the research interest has moved outside the original starting points. Edinburgh, our sister university in Edinburgh, Heriot Water involved, Strathclyde across the west coast of Scotland, Lancaster, one of the original institutions, is still active, joined by Southampton, Manchester, Exeter, Plymouth, Hull, Belfast, another one of the originals, Robert Gordon, Aberdeen, UHI, University of Highland and Islands, Oxford. I always miss somebody out, and if there's anybody at Sheffield working on marine energy, I'm sorry if I've missed you out, I apologise. But most of these groups are small. Some of them are only one person, and this has caused some confusion on the development and the way forward. So it's not too surprising that the Research Council has tried to pool as much of this together as possible. And for the past 7 years, they funded much of the research through the Supergen programme. The present Supergen programme, and it changes every few years, consists of ourselves, Queen's in Belfast, Heriot Water, Strathclyde and Lancaster, and a broader network of affiliates who receive PhD students. Try to pool the activities together. They range from some fairly esoteric numerical work right through to economics and ecological consequences. It's not just mechanical and electrical engineering that are involved in this programme. But it's not really the research itself that I'm talking about. I want to look at the development. Have a look at the prototype devices that are now operating. This is Limpet on Islay. This is the direct development of Trevor Whitaker's original device. It's rated at 500 kilowatts, at the small side. It's a coastal device. It uses the principles of the oscillating water column. Lots of people have photographs from this side. I'm very proud of that photograph. However, not so many people have taken photographs from there, and I'm not going to do it again. This is Polamis, developed by the Edinburgh company, now called Polamis Wave Power, originally called Ocean Power Development. Sometimes it's called the Sea Snake. It's a flexible articulated cylinder with hydraulic power takeoff at the joints. This photograph shows the power modules being constructed at a subsea fabricator just outside Aberdeen, an example of the oil and gas industry providing expertise into this new marine renewable industry. This was tested some 5-6 years ago in Orkney. So it's not new. A bit more up to date, this is Seagen, tidal current turbine in Strangford Lough in Northern Ireland. It's a twin horizontal axis turbine device rated at 1.2 megawatts. This is its predecessor, Seaflow, in the Bristol Channel, which was much smaller, rated at about 300 kilowatts, but both of these devices have proven intensely successful. Interestingly, this one in particular has been monitored for its interaction with marine mammals. And over nearly 2 years now of continual operation, there is no evidence of any detrimental impact in one of the densest populations of grey seals and harbour seals in Europe, which is very satisfying considering the aims that we're trying to achieve.